Hey, everybody. I'm here with Dave, the founder and CEO of Optimal Agriculture. Thanks for joining us, Dave.
Great to be here, Emmett.
So I'm really excited to learn a little bit more about Optimal. What do you guys do?
So, yeah, we build AI software to optimize and control huge greenhouses. You can think, imagine a glass box the size of the Tesla Gigafactory in Nevada, producing crops such as tomatoes, cucumbers, and lettuce, and so on. Right now, these greenhouses are human operated, and we're developing AI software to kind of bring them to the next level, optimize yields, energy efficiency, and the scalability of these.
Yeah, tell me about the founding story. It's really interesting. Like, how did you realize this was a problem, and why did you guys decide to attack it?
So my background has been in reinforcement learning. So I was part of the reinforcement learning research group at Oxford University, and we were working very closely with Google DeepMind on reinforcement learning agents. And DeepMind, they did a project where they applied RL to optimize a data center, and they managed to reduce the energy consumption of that data center by 40%. So that was obviously a monumental result and, amazing application of RL. And I was inspired by that to look at other important areas, other critical infrastructure where RL could be applied to either improve the reliability or scalability or efficiency of that infrastructure. And I've always had a big interest in agriculture and food production and food availability. And so that's how I kind of discovered the greenhouse industry. And I honestly had absolutely no idea how big these greenhouses were, or honestly that they even existed. It's one of those kind of weird industries that no one knows too much about, but yet everyone benefits from. And if you go to the supermarkets today, you're going to find produce in there that's grown by greenhouses. And so I just started cold calling greenhouse operators, telling them about RL. And I got invited to spend some time with some of the largest greenhouse operators in the world. So, a lot of them are based in the Netherlands. That's kind of a home of the greenhouse industry. And so I booked a one-way flight to the Netherlands, and I spent a very cold winter, working in one of the largest greenhouse operations in the world, based just north of Amsterdam. I'm really just immersing myself in greenhouses and understanding how crops are grown, understanding all the control systems that are currently in place, what the growers do, what the other greenhouse operators do. And I saw a huge opportunity to apply reinforcement learning, and to be able to give these greenhouse operators the tools to be able to grow much more reliably and much more efficiently. And so that's kind of how I got into it. I kind of fell into it whilst was following my curiosity.
Yeah, this is fascinating to me because it's a completely different field. You haven't spent time in it before. Did you have what made you realize as you were doing your research that greenhouses could be the right application for what you've been learning? Like, was there something in particular? Did you look at other industries or other types of infrastructure?
Yeah, I mean, first of all, I just saw, it was very obvious the global importance of greenhouses. In order to get certain fruits and vegetables year round at a certain quality level, you actually can only grow them indoors. You can't rely on field farming. Field farming doesn't get you the same quality level, and it doesn't allow you to have year-round supply. So for a lot of these crop types, greenhouses is the only way to supply them. And so, because of increasing demand for healthier, higher quality fruits and vegetables, because we have climate change, which is really drastically affecting the yields of field farming, and because we have shortages of resources, like especially resources like water and land, greenhouses are becoming more and more important and more demanded. And in many areas in the world now, either it's a case of the only way you can get certain crops at a certain quality level is through a greenhouse. It's the only food production method that will supply that. Or it's a case where greenhouses now have met cost parity with field farming. And so you're starting to see a shift from field farming into kind of these high-tech greenhouses. And so I just saw that there was a huge demand for these greenhouse projects. But there was a big problem, which is that these greenhouses today rely on human operators, and there's a very, very limited supply of people who've spent the 10 plus years required to train to become a greenhouse operator. And there's an especially short supply of those operators in places like the US, Mexico, Southeast Asia, China, Middle East, which are kind of sort of new greenhouse markets. And so we we've got this incredible infrastructure which can be scaled very quickly, but we just don't have the human
Right.
operators to run these greenhouses. And
So
so that's kind of what attracted me to it.
when you went into the space, like, can you help me visualize like how reinforcement learning can actually make these things better? Is it, the timetables that people work, like, or how the crops are fertilized, or like what's the kind of mechanism to making the system work better with reinforcement learning?
So there's thousands of sensors in these greenhouses which capture all sorts of variables, everything from the stem diameter of a crop, that's measured in real time. You've got cameras inside these greenhouses. You've got temperature sensors, root zone humidity sensors. You've got weather stations. So you've got a huge number of data streams coming from these greenhouses. And the dynamics of the environment are very complicated. You've got crop biology. You've got fluid dynamics. And so you've really got this kind of interesting optimization problem with lots of data, nonlinear dynamics, a lot of uncertainty because the weather is uncertain. And so how do you control a complex system with nonlinear dynamics where there's a lot of uncertainty and where you've got a lot of data? Well, this is kind of like the perfect setup for reinforcement learning. And right now you've got these human operators who just do not have the tools to be able to control this environment. And so there's just a lot of potential there for RL.
So why is this possible today when it wasn't maybe possible before? Is there a specific why now, or is it just that it needed someone like you to actually realize that there's an opportunity here?
I think it's a combination of, like any opportunity, it's a combination of things that makes the opportunity good. One is that the increasing demand for greenhouse grown produce and greenhouses for all the reasons I mentioned. Another big one is obviously climate change, but also global instability. Countries wanting to grow food within their own borders, and so there's a lot more investment capital available to build new greenhouses. So that's one thing. Then the other thing is just the shortage of skilled operators. The average age of a greenhouse operator in the Netherlands is 60 years old today.
Oh, wow.
So in the Netherlands, which is like the OG greenhouse market, you've got a shrinking of the number of greenhouse operators. I mean, in new markets, you just haven't got the operators at all.
Right.
And so it's like a supply of labor, essentially skilled labor, and the shortage of that. And then the third piece is the fact that you've got RL systems and availability of compute now, which is able to run these kind of big and solve these big optimization problems fast enough to be able to implement the decisions in the greenhouse. So there's a combination of demand for greenhouses, shortage of skilled labor, and cloud compute and algorithms being kind of ready to handle this control problem.
So what's your pitch to candidates? Like, why is Optimal a great place to work?
Well, because you can have a real big direct impact on agriculture and on food production. The bottleneck to scale for greenhouses is the shortage of skilled greenhouse operators. The infrastructure is very easily deployable, very quickly deployed. The capital is there to deploy new infrastructure. The single bottleneck is the availability of skilled operators. Optimal is directly attacking and solving that bottleneck. So coming to work at Optimal, you get to remove this bottleneck. You get to directly contribute towards build out of new greenhouses around the world and to increase efficiency of existing greenhouses. And therefore to, the reliability of our food production chain, the availability of food, bringing down the cost of food, and so on. So it's very rare that you get to join a company that's applying interesting technology, but is attacking a key bottleneck in a system that allows huge impact on a global scale.
And then, do you guys have some traction, customers, like investors? What does the kind of the picture look like in terms of how you all are progressing towards the goals?
Yeah, so we've spent the last few years developing the software in our own greenhouse. So we actually have been leasing and operating a large commercial greenhouse in the Netherlands. So we've spent the last few years actually being tomato and cucumber growers, selling produce to retailers in the Netherlands, really as a way to develop the technology and prove that it works. One thing about agriculture is that people are pretty risk averse. Like, the technology has to work before people are going to adopt it. You need to prove that it's going to work before people are going to buy that and risk that in their own farms. So we've done that. We've proven that the technology works. We've got the results, and that's now unlocked our first customer contract. So we've got customers now in North America and Europe, and we're building the team now to service these customers.
And what do the next few milestones look like? Like, what do you need to prove to kind of prove that you're heading towards your big vision?
We have to replicate the results we've achieved within our own greenhouse in our customer greenhouses, show that we can improve yields, improve energy efficiency for them, improve the reliability of production, make them delighted with the product. At that stage, we've really kind of proven like the product market fit. We'll raise the next round and scale out to more greenhouses. We have partnerships in place with two of the three largest incumbent greenhouse control systems companies. Those two companies have 75% market share. So we've got access basically to 75% of the world's greenhouses in terms of the ability to deploy our software. And so, it's up to us now to make these first customers happy and then to scale up the company from there.
That's awesome. So can you paint me a picture of like what the team looks like right now? How many people are you trying to hire right now?
Yeah, so right now it's me and my colleague based in the Netherlands, and we're expanding our engineering team to service these two customers. So we've got 4 open roles. We're hiring on the simulation and control side, and we're hiring on the software engineering side.
It's really interesting that you guys are early. Like, have you thought about how you were trying to think about kind of your company culture, like how you guys want to work and all of that other stuff? Obviously, going from 2 founders that are working together on something versus kind of scaling it out. Have you put any thought into what you want the company to look like as you bring more people on?
Yeah, I've thought a lot. I thought very hard about that because the nature of our work is distributed. I mean, our customers are greenhouse owners, greenhouse operators. These greenhouses are not in the middle of major cities. They're in places which are good for greenhouses, which are usually fairly remote locations. And so, how do we as a company avoid ivory tower engineering? How do we make sure that we really understand what it takes to operate a greenhouse and kind of don't get too disconnected from the work that our customers are doing? And so, we obviously solved that directly over the last couple of years by operating our own greenhouse. Now we're focusing on rolling out to customers. It's important we maintain that culture. And so, in the office, we have, we basically bring the greenhouse into the office. We have like big TV screens up on the wall, big monitors up on the wall, which show, real-time images from a greenhouse. You can see all the dashboards, you see all the data, see what's currently going on in our customer greenhouses. And so we've set up the office almost like a command and control center for greenhouses. And as we expand the team, I imagine that will expand to look, like a kind of mission control center from some kind of rocket company, except instead of rockets is greenhouses. And so that's how we're bringing the feel of a greenhouse to the office.
You guys have done a lot. You did a lot, right? Like you've operated in the greenhouse. You worked in a greenhouse before. You've like felt the problems kind of at a day-to-day. Obviously, the people that you bring on might have like a step removed from that. So is there things beyond kind of like showing the greenhouse that you guys want to do to kind of make sure the engineers are actually like feeling the pain that an operator would feel running these things?
I mean, yeah, the way we're going to do that is just do a lot of visits to greenhouses. So as part of the onboarding process for a new hire, when a new hire joins, almost within the first couple of weeks, depending on obviously the person's availability, we're going to go to one of our customer greenhouses, spend some time there, and just kind of see how crops are grown in these environments. And then we do regular trips to customer greenhouses with the team, just so we remain kind of immersed in that environment and don't get disconnected from it. It's super exciting. Like you go to one of these greenhouses and they're mind-blowingly huge, and it's always fun to go back and see what your software is controlling and get back into the problem and experience it firsthand.
That's really cool. Yeah, it's just like being immersed in something. It's always like it almost feels real. Like it feels real. Like software sometimes can feel kind of very like separated or not tangible. And I think like actually seeing the greenhouse, that's just really cool.
Well, so, I think it's I was going to say on that point, I think it's kind of interesting. The software is interesting. The software we're building because it's controlling such a huge piece of infrastructure. These greenhouses cost anywhere up to $50-60 million to build, and our software is controlling these greenhouses in real time. So that's pretty cool. I mean, how many opportunities do you get to write software that controls like essentially a $60 million robot that produces
How
food.
do you test in this situation? How do you do QA in this type of situation where, like, it's controlling a massive system that if you make mistakes, you could lose yields of crops and the whole deal? Like, how do you make sure that things are working well and that, but you're also able to make progress and move quickly?
Yeah, so we have a phased approach to rolling out new control algorithms. Um, we have a staging environment, which is essentially what we call software in the loop. So we have a greenhouse simulator, which is written in code,
I don't know. Nice.
and we test our control algorithms versus the simulator. And then there's various techniques to address the kind of simulator to real gap, and make sure that the performance we get in the simulated environment is closely matches the real environment. And then when we roll out to the actual greenhouse, again we roll out in a phased approach, and obviously we're watching very carefully, because they're like any kind of control system. There's always a sort of some disconnect between the simulator and the real world, and so you never really know for 100% sure until you're actually deployed in the live environment. And so there's a lot of also just watching very carefully what the system does when we first deploy it in the live environment.
I had a specific thing I was going to ask you. Oh yes, okay. So this year, like, you're hiring a lot of people. What are the big projects that people would be taking on when they join the company for this year?
Well, we've proven an environmental control system, which has proven to increase yields in our own greenhouse. We now have to take that to customer greenhouses. And so, there's kind of two kind of big technical challenges that need to be solved to get that done. One is, how do we adapt the simulator models and control systems that we have to work on customer greenhouses? There's a lot of standardization with greenhouses, but greenhouses are different shapes. Some of them have different actuators, and so how do we model those new actuators, get our simulators working on customer greenhouses, and get our control systems working? So there's that kind of simulation control challenge we need to go through, and then automate as we scale up to more greenhouses. And then on the software side, like I said, our control system has been proven to work on our own greenhouse. Now we have to deploy that in customer greenhouses and deploy to more and more greenhouses. So there's a very interesting scaling problem on the software side. How do you ensure the system is reliable, is available 24/7? Like, we can't have an outage. An outage means the crops might die, or at least we suffer a big reduction in yield. So the system's got to be working 24/7, and it needs to be scalable. We need to be able to scale that up to more greenhouses.
Can you tell me a little bit about, who you're looking to hire? Like, are there attributes that will predict success at your company? I know obviously it's you and a founder now, but like, are there specific things that you're looking to hire for specifically to bring onto the team?
I think the main thing is just a real focus on getting technology working in the real world. Our customers are trusting us with their greenhouses, and with millions of dollars of potential loss or potential improved profit based on the performance of our system. And that's a lot of trust they put on us. So one big thing is just a real focus on getting the technology working in the real world, and that real kind of practical nuts and bolts type engineering culture. The other thing is just the willingness to learn. We're applying techniques from reinforcement learning and optimal control and predictive control to optimize high-tech greenhouses. Well, no one's really doing this. So no control engineer is going to come into the company, or no reinforcement learning engineer is going to come into the company knowing how crops work. You'll need to dust off your school and college level biology to remind yourself, like, that crops transpire, that there's a photosynthesis process, and so on. So there's the other thing, that willingness to learn. Like, we can't hire anyone who directly has all the skills needed to be able to deliver this system. And so you've got to learn something, and you got to learn.
Can you tell me a little bit about how you guys interview? Like, what does the interview process look like for a new engineer?
Yeah, because we're building up the engineering team, and it's an early stage process. Then there's a lot of one-on-one time with me and with my colleague. So we'll do a kind of filter interview, and then usually we go straight into technical interviews. So for a simulation and control role, and we have a modeling optimization and control deep dive interview. We have a software interview, which is a bit like a pair programming type interview where we kind of solve some problems together, and it's usually a lot of fun. And then, we have a kind of much longer interview, kind of one-on-one with me, just to kind of get to know each other and make sure there's a fit in terms of what you're looking for your next role, and what we need in order to get the job done and deliver to customers. And then we make an offer. And usually the process is extremely quick. We can go from a first call to an offer within a week.
That's awesome. Yeah, I'm really interested. I looked at your resume, and it's really interesting. You've been part of what you call university. You've been algorithmic trading, and
Yeah.
now you've started your company. Like, can you tell me a little bit about like kind of what you've learned? Some things that might have been surprising, or that you didn't expect in your journey of becoming a founder.
Yeah, I always, when I was younger, I always assumed career paths were linear.
Hmm.
And I always thought for myself that I would end up, just on this kind of very linear trajectory. And the funny thing is, I've had one of the most varied careers, I guess you could call it, versus a lot of people I know. I came out of university. I was working with algorithmic trading. I was in the right place at the right time there, where the whole market essentially was moving towards electronic trading. And then now Optimal is building software to grow crops within greenhouses. So I think for me, I've been surprised at how the career has gone looking backwards, but really all I've been doing is following my own curiosity. I really believe in the power of technology to improve things in the real world, and I really believe in engineering and actually getting technology deployed, getting systems actually working. And I've really just kind of followed my own curiosity and just seen where I can be most useful. And that's really how I made my decisions.
That's awesome. Well, thanks, Dave. This has been really cool. I haven't talked to a company that's building like these massive robot systems at scale. So it was really cool to kind of hear a little bit more about them. Thank you so much for your time. And if people want to learn more about optimal agriculture, where should they go?
They can go to our website, optimal.ag. There's some information on there, or they can contact me directly. It's Dave, Dave, @optimal.ag. Happy to chat to anyone who's interested in learning more about greenhouses.
Awesome. Thanks, Dave.